Hi, my name is Nenad Petrović. I'm coming from University of Niš, Faculty of Electronic Engineering, Department of Computer Science. Now, I will present a paper that we brought together with my colleagues from Telecommunications Department, Professor Dejan Milić, Suad Suljović, PhD, Samir Koničanin, and Stefan Panić from University of Priština, Faculty of Natural Sciences. The main topic of this paper is the transmission of signals under the influence of kappa-mu fading, which models a random process of changing the amplitude of a useful signal using a relay system based on the decode and forward technique. The main contribution of this paper is derivation of infinite series expression observing important wireless performance criteria for outage probability. Moreover, we present a software tool that is used to illustrate the proposed approach that allows modeling and simulation of smart city scenarios. In wireless communications, a variation of received signal value is a very common effect due to multipath propagation. In this context, fading is one of the main causes of system performance degradation. However, wireless systems in general suffer from problems that are introduced by multipath fading and shadowing. Considerable efforts have been devoted to statistically model these effects. In modern telecommunications, a practical technique for providing both wider and more efficient coverage is relay transmission. When it comes to multi-hop transmission systems, they can be classified into two major categories, depending on the nature and complexity of their relay. The first one are so-called regenerative systems. Decode and forward is one of them. The second group are so-called non-renewable or non-regenerative systems, where the representative is amplify and forward technique. In decode and forward technique, the relay decodes the signal obtained from the source and then re-encodes it before sending the signal to the destination. In this paper, we consider a wireless communication system operating over the proposed fading channel. The outage probability of a system is of great importance for designing the parameters of wireless communication systems in order to meet the requirements of both quality of service and grade of service. Based on the outage probability, the area of coverage of the cellular system and the minimum distance between the two base stations for which frequency area reuse is possible can be determined. This slide shows the illustration of a relay signal transmission model based on DF technique, in a system which is under the effect of kappa-mu fading. Within the scope of this paper, we consider the relay signal transmission along the source relay destination link. In case of relay signal transmission based on the obtained first and second order statistical quantities at reception, we can perform an analysis and performance evaluation of the entire wireless system when no diversity technique is applied. In dual transmission, the communication from source S to destination D via relay R occurs at two time intervals. In a first time interval, source S sends a signal to relay R. In the second time interval, the relay R decodes the signal obtained from the source S, then re-encodes it and sends it back to destination D. In this paper, for relay signal transmission by the DF technique, we assume that the value of the relay power constant C is 1. For the model signal transmission, subject to the influence of kappa-mu fading on source relay destination links, this paper mathematically evaluates and graphically depicts the outage probability of system on reception using the Mathematica, Origin software packages, and JavaScript in case of simulation environment. The probability density function of the current signal-to-noise ratio value is given in equation 5. In this case, kappa is the ratio of the direct and the scattered component. On the other side, the cumulative distribution function of the current signal-to-noise ratio value for the kappa-mu distribution is shown in equation 6. The outage probability of the proposed system is expressed as equation number 1. In this equation, the kappa is ratio of direct and the scattered component, Capital gamma is a gamma function. Mu is the number of clusters. Gamma stands for converting the signal strength to signal to noise ratio, S and R. And finally, W is the mean signal to noise ratio value. A software environment for modeling and simulation is implemented using HTML, CSS, JavaScript, and is run within the web browser. It offers three types of elements in order to simulate smart city scenarios. The service access points, such as base stations, are used by the consumers in order to access the network. The service users, in our case, are autonomous cars. The fixed elements are obstacles, buildings, and other objects that could affect the overall quality of service. For purpose of software simulation, several mechanisms are implemented within the web browser environment. Quality of service variation is performed according to several factors. First, it is affected by the distance from obstacles. Second, it's affected by the distance from base stations. Third, it is affected by the number of users connected to the same base station within the area. And finally, the first and second order statistical measurements are also taken into account. On the other side, service adaptivity mechanisms are also taken into account. When quality of service value drops below certain predefined threshold, then corresponding action is taken. This action can be either network or some other optimization. The results obtained for outage probability for varying values of parameters mu, kappa and gamma are shown graphically. We can see that if parameters mu and kappa increase, the outage probability of a system for positive values of W decreases and the systems become more stable. The work presented in this paper analyzes the outage probability of a system that transmits a useful signal which is modeled by kappa mu fading using the DEF technique without diversity reception. In terms of system performance, an increase in the mu parameter, or rather a decrease in the number of scattering clusters, leads to better system performance. In the case of relaying without diversity combining, the outage probability depends mostly on the receiver sensitivity threshold as expected. Obtained results can be used in performance analysis of a wireless communication system operating over kappa mu multipath fading channel. This work has been supported by the Ministry of Education, Science and Technological Development of the Republic of Serbia. Thank you for your attention.